This will be the first video where we get into a concept known as factoring. And what we're going to look at today is factoring out a GCF, a greatest common factor. So I want to first talk about what factors are. Factors are two things, or more than two things, that multiply together to give us something. For instance, the number 12 has factors of 3 and 4, because 3 times 4 is 12. Or 2 times 2 times 3, because 2 times 2 times 3 is 12. It's when we write any quantity as the product of other things. So that's our goal with these algebraic expressions. We're going to start by looking at the distributive property. This problem up at the top, 8 times 3x plus 1, distribute. So we get 24x plus 8. We've been doing that. That's the distributive property. We're doing 8 times 3x and 8 times 1. What we're looking at today with factoring out a GCF is we are going in reverse. We are starting with an expression like that and getting it written as something where we would use the distributive property to simplify it. Factoring is unsimplifying a problem. So we look at this second problem here, 6x minus 15. Look at the 6, look at the 15. What is the greatest common factor there? What number goes into both of them? Well, 3 does. So we can undistribute the 3. We're pulling it out of both of these. We're dividing it out. We're unmultiplying. So 3 times what? 3 times what gives us 6x? 3 times 2x would give us 6x. And we can check by multiplying those together, and we should get this first term. Now 3 times what gives me negative 15? 3 times negative 5. We're unmultiplying. We're dividing 15 by this 3, and the negative needs to come down also. So we're going to go through a quick little plethora of examples here, look at some different ways that you'll see these kinds of problems, and then it's off to the races and you'll be practicing. Okay, so top one, 2x squared plus 4x. What's the GCF there? Well, here you got to be a little bit careful because we have to look at the coefficients and you have to look at the variables because both terms have x's here. So both of those things are divisible by 2, but they also both have x's. So 2x times what gives us 2x squared? 2x times another x. And then 2x times what gives me the plus 4x? That's going to be plus 2. And we can check by distributing. 2x times x is 2x squared. 2x times 2 is 4x. That's what we need. The second example, look at the coefficients first. 3, negative 4. Is there anything in common there? Is there a greatest common factor other than 1? And no, there's not. So this time, we are not going to be bringing a coefficient, a number, outside the parentheses here. But we see that they both have x's and they both have y's. So we've got x squared and x. We can take an x out. And then we have y and y squared. We can take a y out. So xy times what gives us this? Well, we need a 3, that's for sure. And if we took xy times 3, we'd have 3 times xy. But we want 3 times x squared y. So what else do we need? We need another x. And then we're doing xy times what gives us minus 4xy squared. Well, we know we're going to need that minus 4. But now, if we just left it that way, when we distribute, we would have xy times negative 4, which is negative 4xy. We want negative 4xy squared, so what else do we need here? We also need a y. And there's our factored form. Last example for today. I'd like you to try this. I know it looks a little different than what I've had on here, but pause the video, give it a try, see what you can come up with. Okay, I hope you've put together that in the parentheses we're going to need 3 terms, 1 spot for each one of these. And what is the GCF here? The GCF is 2. They don't all have x's. The first 2 terms have x's, but all 3 of them don't have x's, so I cannot take an x as part of my GCF. All the coefficients are divisible by 2. So 2 times what is 6x squared? 2 times 3x squared. 2 times what is negative 8x? Negative 4x. And 2 times what is 12? 2 times 12 is, or 2 times 6 is 12. So our factored form is 2 times 3x squared minus 4x plus 6. And with all the rest of the factoring that we're going to be doing, we'll do it in many different forms. It's always important that you make sure that you take the greatest common factor out first. Get that part factored out. It will make the numbers smaller and easier to deal with.